Good afternoon and good morning. Thank you for joining for another masterclass. We're here with Mr. Charles DeForge, one of the people that I've known for, oh my God. Charles, how long have we known each other now?
7 years?
I was going to say since birth, because our birthdays are actually on the same day, which took us 5 years to figure out.
That's right.
So thank you for joining us. This masterclass, we've actually, gotten a lot of feedback on how to improve. So we've changed a couple things in order to make it more interactive and actually to get to your questions a little bit better and to understand where everybody is in terms of what they expect from the topic of finding a profitable niche in metal AM. So just as we always introduce ourselves, my name is Matt. I've been working in the additive industry for 8-9 years now. Mr. DeForge is someone that I've had a lot of contact with from the beginning. He has actually, the first time that they actually acquired a system, we've been working together since then. He is the founder and managing director of Spartacus 3D. It's a company that is focused on metal AM, specifically laser powder bed fusion. They will go a little bit into what they do in a second. But yeah, I really like working with Spartacus because of the kinds of applications and solutions that they deliver to the industry. So it's really exciting for him to be here, and actually we're going to share some experiences that we've had together in terms of profitability in metal AM. So just to get into it, the masterclass is just in the same layout as before. We have a 30-minute discussion. The first focus is on theory. The second focus is on the actual lessons that Mr. DeForge is going to deliver to us. You can ask any questions at any point in the talk. And then the final 10 minutes is going to be a Q&A. So we have some questions prepared, and I didn't send it to you just to surprise you a little bit. And we actually do have a little bit of surprise from Mr. DeForge himself, because I thought this was really exciting to kind of analyze and give him some insights into what he's been working on. If you have any questions that you don't want to talk about during the class, you can always schedule a one-on-one 30-minute session, completely free, not a problem. I understand that not everybody's an extrovert, and I always underline that point that you don't have to ask your questions in the middle of everybody else talking about things. So just to get started, we're going to talk about how a project phase, how projects can be broken into different phases, and analysis of those results. We will then get into something that we've discussed before, which is value stream mapping, and how we can use that as a strategic tool in this example. So if you haven't seen the previous masterclasses, you are going to fail the course if you don't see it by the end of this weekend. So go ahead and go on our website. The videos are available there, along with all the theory explaining of what we do. In this example, we will actually analyze 2 builds, and that's kind of the surprise for Mr. DeForge. And then we will talk about vertical niches in metal AM. And then we'll turn it over to him in order to talk about his experiences in production in metal AM. So the first thing that I guess we should talk about from the theoretical side is we can divide a project into the individual roles that individuals have. So from the perspective of the project manager, from the perspective of the machine operator, as well as from the perspective of the machine. And so what the project manager sees is that he is just preparing the data. And this is, of course, before the build happens, because the project manager is someone in our persona identification as the person that actually handles the project throughout its entire production cycle. The machine operator, on the other hand, is the person that is preparing the machine before the project starts. And then, of course, the machine sees the building and also the machine preparation side of things from the machine operator perspective. So now, of course, if you can imagine, one project is very simple. It's a very linear process, and you're kind of wondering, why are we even doing this? Well, as you imagine, when you add more and more projects, there's a lot more tasks that go into it. And so if you add a second project, this is how it looks like. The machine operator has a little bit of time in between, for which he does have a lot of other tasks to do that are not related to a certain project. The project manager, on the other hand, has a very relatively fixed amount of time that he spends on data preparation, and then this continues. And so either we coordinate the production from the perspective of one machine, or we have to kind of, ignore the complexity of this. And that's what we will do for the sake of this conversation, because in this context, what we're doing is we're trying to analyze a single project. So when we have the single project, we have the project manager preparing the data, and then of course he has to do other steps afterwards. Now, if you take a look at it from the perspective of the project itself, this is how the workflow looks like. And of course, it's different for every production and it's different for every application, but this is more or less the idea. So you have the data preparation step, you have the machine preparation, then comes the build, then comes the post-processing and the quality control, and those have many different iterations. But for all intents and purposes, that first step is relatively fixed, or we say that it should be fixed. Then the build time is variable depending on the project that you're working on. And then there's finally the post-processing and quality control, which is a relatively fixed process. So when we take a look at this, the first question that you really want to ask yourself is, what is the ratio of this setup time of the machine and the project with relation to the variable aspect of the production, right? And why is that important? It's important because we need to have that as a metric in order to understand of whether we are doing things well. And that's just another KPI that we can integrate very easily in order to understand how efficiently we are doing things and the decisions that we make in our production. And I think one of the really big aspects of this is that nobody asked this question, or very few people have the answer to this question, is what is the cutoff, right? So when we have this ratio of the variable time versus the fixed time, is there a certain amount at which you say this is unacceptable? Do we not take this project? And I think that the answer for most people is going to be no, there isn't a time like that. And that's really important, that we do need to understand our value in terms of what we're doing in production. And this is one of the KPIs that we can use, is saying, hey, the build time for this project is way too short. We cannot do this. So one of the other things that we analyze from this perspective is from the value stream mapping side, is how our time is used. So we divide the work into RVA, OVA, and NVA. And the way that the data, or that the steps in the production fit into these three categories, is by answering the questions that we have here. So a real value adding project is something that brings value to the customer and the organization. An operational value adding step is something that is necessary for us to deliver value to our customer. However, it's not necessarily useful for the customer because they either don't pay for it, or they don't really care for it. So if you would be able to automate that step, then that would be an OVA, that is, we're doing it at this point, but maybe it's not worth, investing our time into automating it, or maybe outsource it. And finally, there's the NVA, is non-value adding. Means it does not bring any value to the customer, and it does not bring any value to your organization. And now, why is that important? It's something that actually alludes to a lot of losses that we have in production. And then we can actually make decisions on how we should go forward in terms of finding profitability. Because when you take a look at a single machine and the projects that are running on the machine, we have the machine preparation, we have the build time, and that's great. At a certain point, we might have a powder change. Then we have, again, machine preparation and build time. And nobody actually talks about, what does this mean for our organization? And is this absolutely necessary? So usually we say, yes, a powder change is necessary because I have these projects that the customer has asked me to manufacture, and I know I can change the powder. I have the parameter set, I have the powder available. The machine is capable of printing this. However, what does that mean for our big strategic focus, right? So when we actually break it down into our OVA, RVA, and NVA, we see that the powder change is a non-value adding operation because the customer doesn't pay for it and the organization doesn't really need it, right? It's a necessity because of the fact that we don't have an additional machine. Now, ideally, every build could be done with a different powder, but that's not realistic. In a production environment, that's not something that we could very easily do, especially when we have a qualified process. So what we do is we take a look at these and we again ask ourselves a question: how many times can I change the powder, right? And what is that ratio of RVA to NVA and OVA steps? It has a direct impact on our system efficiency because of the fact that those things are, topics that a customer will not pay for. So if something is not being done, we have to understand what is the opportunity cost for not doing that step or for doing that step, right? What could we do alternatively? Now, sometimes people would say, let's just not run the machine. And on the face of it, it first seems like a crazy idea. However, if I show you that, that you're losing a lot of money, then yeah, you wouldn't do it. However, we're not able to quantify it. And this is where people have a challenge in terms of saying, yes, let's not do that. And so when we use the example of a powder change, the question is, how do you decide when to change powders? And it should not be based on a production queue. which from our first class, you would understand what a production queue is, but more importantly, if another customer approaches you and says, hey, I want you to change this machine to this material because I have 17 projects on that, you have to be able to say, does that make sense for us, right? So that you're not being led by the customer. And the important aspect of that is the fact that you have to be able to understand your value to the end user, right? Of course, you want to be there for the customer, but you have to do it in a way that is sustainable for both of you. Because if the customer is asking you for things and you don't know what your value is, then the problem is that you're going to be losing a lot of money and you're going to be slowing down your organization, because potentially, instead of doing that powder change, you could be doing business development in terms of getting another project in that material and just deflecting that to someone else to do, or actually just saying, sorry, we can't do it. So one surprise that I had from Mr. DeForge is he presented us with 2 builds that he's worked on, and we had a very really interesting discussion about something similar before. And the 2 builds, the way we analyze the analytics in Optima, we actually don't get the geometry. We have, what we do is we collect metadata from the project. But based on that information, what we can do is we can understand some aspects of the production. And so the material in this case is aluminum, AL-Si10Mg. The machine that we were running this on was EOS M280. And we wanted to analyze what is the efficiency of this project. And the efficiency of this project was 54%. The build time was 60 hours. The data preparation took about 8 hours. The machine preparation was about 2 hours. That's all fine. The complexity of this job is 62. We're not going to get into that topic, but basically, as the number is higher, the complexity is higher of the job, and complexity is never free. So what that means is that complexity is something that we have to consider in terms of how we calculate what is the value adding for the end user and how do we charge for that. Because as we can see, the AMI in this case is 54% out of 100, meaning that we have an opportunity cost. In other words, a loss in production and productivity of 27.6 hours, which means that we could be using those 27.6 hours for something else. And this is the first time that he gets to see these numbers, and I can see his eyes are not very good. So this was a surprise. Now, the other project that we worked on is something that is actually a lot smaller of a job, and the AMI came out to be 90%, even though the complexity was 123, meaning that it was much higher complexity geometry. And again, the machine preparation was about the same. However, the data preparation was 14 hours, and the build time was only 12. So now the opportunity cost in this case is only 1.2 hours. However, that is an opportunity cost, which, you know, who's going to pay for that, right? And the question is which project should you do? And I guess looking from his face right now, this is the first time we've ever done this. This is fantastic. Looking from his face right now, on the one hand, that first project should have had an adjusted machine hourly rate and by a factor of 86%. And instead, we just charged for 60 hours of building time. And that means that we left a lot of money on the table. And what's more important is that a company like Spartacus 3D in that case is being treated as a commodity. And that's not fair because of the fact that there's a tremendous amount of value added that they're delivering to this qualified application, to this production, that they should be compensated for because of the fact that this is their knowledge and competency that they're delivering. It's not just the fact that their machine is printing. Otherwise, we could just have a huge farm of machines and they would just be printing everything for everyone. But that's of course not the case. So alternatively, what we can do is we can decouple the value of the project from the machine hourly rate. And that's actually something that we wanted to dig into, right? This is the third aspect of profitability that we can focus on. But I really loved your face on that one, by the way. So how do we decouple the value from added production costs, right? What we can do is we can develop a new material, new post-processing, superior quality control, or for example, focus on an application space where we specialize or have application-specific data that nobody else has, or that someone would actually require time to deliver. And this is something where I've seen a lot of service bureaus focus on, and some of the questions that we've gotten are actually related to that area. But I think the major takeaway is we need to do things internally rather than focus on buying the latest and greatest machine, because a lot of times that conversation goes into, can you buy this other machine which has 4 lasers, which is faster? And that's usually a fallacy because, of course, if you can buy it, then everyone else can buy it as well. So how do you develop your own niche and competency, right? That is actually all the due diligence that you do internally. And so we really wanted to bring up, you know, the example of Spartacus 3D, because they have been doing something in that direction. And we wanted to kind of give Mr. DeForge the platform to talk about this. So, and share his experiences, and especially the difficult things. So take it away, Mr. DeForge. Charles. We can't hear you.
Much better when with like that. Okay, let me just switch and share my screen. Thank you, Matt, for this very interesting introduction. As you can all understand, we will talk about more or less the same topics, but slightly different way, but it will lead us to the same conclusion. Sharing is okay? Okay. Yeah, so we only have a few minutes, so I'm going to share just briefly some more information about the company, and then we go deep inside the topic. Okay. Very shortly, briefly, so we are a French company located in Mâcon. Mâcon is more or less in the center of France, basically, not very far from Lyon, for those who know a little bit about France. The company is 6 years old. We are doing about €1 million of revenues, and we are using 4 machines, US machines specifically, and this enables us to work on 4 alloy families: aluminum, titanium, stainless steels, and nickel. We have a very strong focus in aerospace, and that this is the reason why we have this EN 9100 certification. Business fields. So, like I said, large part of the business is done with aerospace. You all know all the big French OEMs such as Safran or Ariane Group, but we are also operating in automotive, transportation, and some other activities that are a little bit right on the slide that seem to be a bit small, but with regard to the topic that we are discussing today, might be of some interest, because this is typically where you can find some profitable niche. So that's something that you should, we all should keep in mind. Okay, added value, not added value. I will just go through our coding model just to explain you how we try to price properly, and of course it's not a success every time. So we start with the cost. It's very basic, but it's important to understand. With any part, I just took any silly part that I had on the computer. We know pretty well the variable costs that Matt mentioned early. Powder consumption, energy, argon, filters, blah, 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 and also all the operator working on. That's something that is pretty easy to manage. The other part of the costs is what I call the AM fixed cost. And that's an important word, because we tend to manage these costs as if they were completely fixed. And of course, it's not exactly the case. And that's all the issue about project complexity that we will discuss later on. What I mean by AM fixed cost is mainly the amortization or the leasing of the machine and all the maintenance contracts. And of course, the people that will work directly on the project. We mentioned the project manager, typically, basically all about engineering and quality specifically for AM. And there are, of course, some other fixed costs that can be overheads, rental, whatever, all the other fixed costs of the company. So this is how we look at the cost, and we try to calculate, to figure the margin of variable costs that will be high enough to cover all the fixed costs for each project, and to give us a little bit of margin at the end. And of course, this is how the price is built and is presented to the customer for any quotes. That's theoretically what we are doing. And the model is working pretty well. But of course, it's very difficult to embrace project complexity with such a coding model. because what I call the AM fixed cost can be very, very tricky to manage, to understand, to calculate properly. If you look at two builds, typically, you can have on one side the same part, 20 parts per build with just one item, and serial production, so production that will come over and over. So the engineering time will be just a few hours for once at the very first builds, and on the other hand, you have a lot of mixed jobs with a lot of different parts, several support strategies, and very likely one-off productions. So how do you evaluate project complexity, and how do you put that in your numbers and in your quoting process? That's very, very tricky. This is the first challenge that we are facing when doing the quotation exercise. And then goes the real life. On the top of the slide, you have exactly what is planned. So we did this technical evaluation. The technical evaluation led us to decide a certain amount of AM fixed costs that will be covered by the margin of variable cost. That's okay. Then we can finalize a quote, we can get the order, and then start going into operations, concretely speaking. So engineering, that can, of course, go as planned. We use all the knowledge management that we have to have a good efficiency in the preparation of the data preparation, and then we go to production. The build time, the real build time is the same as the planned one. We finish the production, we ship, we invoice, everybody is happy. In real life, that's very likely what's not going to happen that way. Technical evaluation, quote and order, of course, will be the same, and that's the whole problem, of course, the whole point. And when we go into engineering, very often the difficulty starts to show up because when you go into more details, support strategy can be a challenge. It can be more challenging than expected. Discussions, internal discussions, internal in the team discussion can be can lead to different ways of supporting the parts, and then when you have planned 4 hours of engineering, you end up with, I don't know, 8 or 10 hours. And then you go to production, and of course, again, the reality can be slightly different from the theory. And you can have, that's typically the picture on the left side, job crashes, typically because of recording issues. And then what happens next? You need to go back into the engineering phase, modify something, and go back in production. And from time to time, you need to do that 1, 2, 3, or 4 times. So of course, at the end, you finish with the part, you ship it, and very often, of course, the delivery will be late. So based on the fact that evaluating the engineering effort is very difficult, plus the fact that in real life, the production might be more difficult than expected, at the end, you have a very poor profitability. Of course, that's a lot of frustration for everyone. And then that's the discussion that we have had with Matt for a long time. We try to switch to value-based pricing. And then if you go in the direction, basically the market is split in two. On the left side, you have low margin applications where you are competing with conventional processes, very often low level of design complexity, one-off productions, and poor profitability. On the other hand, you have all this profitable niche that we were mentioning earlier, and that we will give some examples later, with highly complex designs, thin walls, hollow parts, porous structures, etc. And this is where you can extract yourself from this pricing, a cost-based pricing strategy, and go into a value-based pricing strategy. And that's probably where, but that's not probably, based on our experience, that the only way to make some money in AM, because if you are not on the right side of the slide, then you are on the left side of the slide, and profitability will never be as a level that will cover your cost. Typical niche that we have been that we have experienced in the past 6 years: thin walls, complex geometries like heat exchangers. Again, complex geometries with hydraulic manifolds, very sophisticated tooling. The example that you have on the slide is typically a gripper with internal cooling channels to help improve the life length of the tool. And of course, if another niche would be all these very complex implants. That would be probably the way to get rid of these profitability issues and move to profitable niche. This is it.
Thank you, Charles. So tell me, I guess just some questions directly to you first. Like,
Sure.
how did you feel about the little surprise that we gave you?
Well, of course, I think I'm gonna ask for a 30 minutes private interview to have some explanation about the numbers. But no, I mean it's too short to discuss that. But of course, it's very what I know, what you know very well too, and what we can discuss here, that the complexities of each project is very difficult to evaluate, for sure. And I think that what we've done in the past years, and especially with Optimo, is a very interesting tool to help everyone understand that point. And it's never obvious. So I was pretty sure that you would have a surprise for me, because any production that I look at give different results than expected. Let's take some time later to discuss that.
Yes, sir. Yeah. So just to keep it positive, right? So what if the numbers that you were presented with, right? Like, I know that was a surprise. Now, how would you have that discussion with your customer, right? That was one of the questions that actually came up. Is at what point do you have that discussion where you understand enough of what the customer is doing, and at the same time, let me just share my screen with the Q&A. And at the same time, you deliver to them the message of, you know, okay, this is how much it's going to cost on an hourly basis, but you have to understand that, you know, there's this expression of someone comes in and uses a hammer to fix something, and then he sends a bill for $5,000, and then they go, hey, no, can you please break these costs down? And he gives them a bill for $20 for the hammer, and then $4,980 for his experience, right? And now we keep leaning on that $20 hammer topic with AM, which is just so bizarre to me, because we expect the technology to be revolutionary and 100% reliable, yet at the same time, we understand that it's not. And so on one end, it can deliver highly complex applications that haven't been done before. And on the other hand, we expect it to behave in the same fashion as everything else before has, which is we just charge for a machine hourly rate. So I want to ask you, how do you have that conversation? And the question that actually came up from the group, from the class, is that, is it more efficient to let customers come to you with ideas, or prospect them to introduce them to the technology? And, you know, how is that, like, step on the gas, step on the brake work for you?
Yeah, I think that I don't think there is an approach which is much better than the other. But you're absolutely right. You need to, what we try to do, what we do all the time. The success is not always there, but what we do all the time is to have a kind of discussion just like that in a few minutes and say, okay, guys, don't come with ideas that are, just to summarize, too simple, or that can do with conventional processes. Otherwise, you are immediately on the bad side of the slide, of my slide, and there is no way you can get rid of that, and we will end up by just selling machine hours. Mm-hmm. And if we are lucky, and if we have absolutely no issues in operations, if we are extremely efficient in the data preparation, maybe we will cover our costs, and that's it. Mm-hmm. And that could be a strategy from time to time, especially typically right now when the activity can be slightly lower, but that's it. But we always have the discussion. From time to time, the discussion goes in the direction that is there will be no business just because it's too expensive. But if it's too expensive, it is too expensive. It's not because of our price; it's because of the reality of the technology. So that's possibility number one, no business. Number two would be, okay, we know, we take the business, but we know that we're just covering our costs. And then from time to time, we are on this profitable niche, and then we have a discussion where, and you know it very, very quickly, when price is not an issue. And it doesn't mean that you can do anything, it's of course nothing stupid, but price is not an issue because it's immediately on the value, the discussion is immediately on the value. So when I have a customer coming to me with an idea, I try to understand immediately in which case I am, just to save time for both of us. And yeah, it's the reality is that very often people are coming with ideas that are not relevant for AM. But that's okay.
Yeah. Now, one example in the question was actually, do you invest in redesigning and improving an existing part, right? And I got to say that's kind of a tough question, right? Because if someone is experienced with the additive technology, they do have a better understanding of what to expect, right? Because I think the most frustrating thing for an end user is that you tell them this is going to cost this much, and then you add 50%, and then add 50%, and add 50%. But on the other hand, I mean, that's not bad, right? You will have some utilization. But I think it goes back to, okay, you have this utilization, you're not losing money, but you're losing time, right? And the time aspect is because of the fact that your team members could be doing something more valuable for a bigger picture of the strategy, right? So kind of, logically walking through that conversation, then at the end, it comes out to, we have to have a cohesive strategy that we follow. Otherwise, we're just constantly reacting and we're just as good as our last project, right? So what kind of, I guess, advice, or, I mean, maybe you don't want to disclose this, right? What will be the strategy that you approach in the mid or long term in terms of developing a niche, in terms of developing a specialization rather than just competing on price?
Well, it's pretty difficult to answer the question because by definition, niche are difficult to find. So it's a mixed strategy between looking for them and just looking for business in general and hoping that in the middle of that there will be some niche that will just pop up. So it's pretty tricky. And of course, when we have found something, trying to increase the size of the niche would be the best strategy ever, of course. Typically, when you are good in heat exchangers, that's something, and you can try to expand your business in the field of heat exchanger. And that's very likely a profitable niche. But finding more a new niche, that's really a challenge. It's a lot of different approaches mixed together that can give some results. Just one point on redesigning, when you mentioned redesigning. Of course, it's a very typical topic. You need to redesign parts for AM, but depends what you mean by redesigning. But I've seen very little cases where redesigning the part will make a part which is not profitable going to a part which is profitable. That exists typically if you take a system with several components and you can really redesign everything and transform that to a brand new part with AM, that could be okay. But that doesn't, very often it just improving slightly the design for AM. But if your application was not profitable at the beginning, even with redesigning, it will probably stay unprofitable at the end. So we don't spend much time on redesigning, only if we know from the beginning that the application is right. I have an example in my mind right now. a part that looked very, very simple. It was a tube with a plate, circle plate. It looked extremely simple until I understood that the tube was made by two thin walls. It was completely hollow. And I can't disclose what's inside, but there was something inside. And the design was not for AM. So we had to discover the customer to redesign for him. But at the very beginning, the application was extraordinary for him because it was more or less impossible to do it with another technology. Doesn't mean that we didn't have to redesign it or improve the design, but and that will make the part better, of course, for many reasons. But at the very beginning, it was already a good application. This is typically the profitable niche that we are looking for.
You know, this actually kind of reminds me, one thing that I've read about a year ago was talking about how one of the most required jobs in the world right now is a data scientist. And specifically a data scientist that can actually create a narrative around the data. And I kind of, you know, you're a really good talker in terms of communicating, right? And I think that is actually a huge value added to the people that you work with, because you're engaging, but at the same time, you can help someone in a non-condescending way deliver an application, understand this problem just exactly as you gave that as an example. And that's, I think, something that we really undervalue inside an organization. And so with the current situation, for example, you know, people still value face-to-face contact, right? And for me, that's been definitely an experience where I'm still traveling. Of course, it's very limited because I'm trying to, you know, do my job, do my part in terms of not exposing to any unnecessary risk. But what I think is really key is the fact that, you know, you have this way of communicating and walking the customer through that experience where something like this comes up. And that's really fantastic because that's something that we don't quantify. And again, that's not reflected in the machine hourly rate, where you understand their problem and you actually put them through that entire process in a way that they understand and that they trust you, because they know that you're not going to, you know, charge them for things that are inappropriate. And I think that's also a huge aspect of a profitable niche, because of the fact that you have to guide the customer through this whole thing because they're not there sitting at the machine on a day-to-day basis. And I think that's a huge value added that you as an organization offer, or anybody for that matter that would do that, right? Which is that you know, genuine, human, empathetic contact with the customer where they understand what's going on. And I think that actually leads to the next question, right? Is that one of the people that's joined the class is actually commented on how fragmented the AM space is, and how does that impact profitability? Right? Because on the one hand, you can't expect people to deliver a full-fledged solution in ways that is available in other manufacturing technologies, because there is no specialist for individual areas, right? Or there are, but they're kind of scattered all over. And I think that this is something which we can take as an example from tooling, where in tooling, you have 3 companies that you contact for an injection molded part, and they will optimize different aspects of the process. And so they will develop inherently a niche in different areas of the process. And so it'll be good for one application, but horrible for another application. And at the end of the day, the average is that every one of those companies specializes and makes money, but they make it from different areas. And I think that's a really interesting concept, which I don't know if you have explored in your strategy to kind of understand how you can collaborate and how you can compete with the other players in France, for example, right? Because I know that in France, it's very like focused on, or I think in any country where most of the manufacturing comes from the country, right? You're not going to be looking at business in China. That doesn't make sense. But how you can actually collaborate to actually build up something bigger than what you are as an individual, so that you have a specialization and then kind of work with those other companies in order to hone in your skills and complement what they do. Is that even an option? Is that an advantage or a weakness?
I think I have understood the question. I'm not completely sure because based on the very initial question about the fragmentation in the AM space, but you're absolutely right. I think that the AM space is very much fragmented, and that should open a lot of opportunities for collaboration between companies, because unfortunately for us, unfortunately for some other French players, we didn't succeed in that field. But typically, we had a very, very long and with several discussions with one of our competitors, which was specialized in a field where we are not a field in terms of business fields, but in field of expertise, where we are not at all. Mm-hmm. And on the other hand, it was not in a field of expertise. So, and we were both doing metal AM, both using US machines. So we had a common ground with some dedicated expertise on some material or some application types. So that would have made a great collaboration and increase widely the profitability of both entities, precisely because we could mutualize what we had in common and specialize even more, and then being even better in our fields, respective fields of expertise. Didn't work out for other reasons, but that's life. But you're right. I think the fact that it's very fragmented should open more space for collaboration than for competition. Mm-hmm. But that to go in that way, you need to have a kind of distance with reality and with the numbers, and also a good understanding of the technology, because otherwise what you just see is competition. Mm-hmm. And companies that seem to do exactly the same thing, which is probably not true if you go into details, because everyone will have developed special expertise in something.
Now, tell me, when it comes to your space, we had a question that came up right now is, do you have a formal process to identify what you want to focus on, or is it based on experience and failure?
Can you just say it again, the beginning of the sentence?
Yeah. Do you have a formal process to identify a niche product, or is it more based on experience in review?
No, we could design a process, but it would still be theoretical. Mm-hmm. We could design a process in the way that we could list very kind of precisely some criteria that will make an application potentially a profitable niche or not. Mm-hmm. That's something that is possible. That's something that we have done already, but it's not very useful, because it's very difficult to apply that process to reality. Mm-hmm. That was my point just earlier. Niche are difficult to find. So even if you can describe them very precisely, doesn't mean that you can find them. Mm-hmm. So that's something that we use from time to time, but it's more to analyze prospects or ideas that are coming from prospects, or just people coming to us that just to look for this profitable niche. I'm not sure I'm completely clear about that, but the process exists. It's very difficult to use it.
Mm-hmm. Yeah, so I guess, I mean, innovation, right, as a general philosophy from people that study this, innovation is something that requires quality control and error checking. And that's a really counterintuitive idea, right? Is that innovation means fast iteration steps in a confined space. Like, think outside the box is just one of the most inappropriate statements when it comes to innovation, right? Because innovation actually means thinking inside the box, defining the constraints and actually applying more constraints to what you're doing in order to then become innovative, right? That's when you look at the design process or user-centered design, that's what they actually do. And I think one of those things is, like, defining a process for that is really critical, and it's really valuable, because of the fact that you can then not only communicate it internally to your team members, but also externally to your customers, right? Of what we will do and what we will not do. And I think that that's an exercise that is very, very valuable. And it goes to kind of like the next question that someone asked is how are AI tools working within the working within the additive industry, because we have seen, I won't list any names, but if you're familiar with the industry, you'll know who I'm talking about, is that there are AI tools to scan a company part database and find suitable applications. And the frustrating part about that is that it sounds in theory very good, but generally speaking, when you have tools like this versus an individual, which is again a huge value adding part of what an organization does, is that the tools are really good at executing on rules. And now if you have an AI tool, which by the way, if we're talking about the people in the industry, I really question that it's actually artificial intelligence, because it means that it makes decisions independent of what you've coded it for. And a lot of people kind of underestimate that because we just love using the word AI now, right? But it's very
deep learning or something like that.
Exactly. And how do those AI tools help in identifying suitable applications when we have to have that discussion with the customer, right? Where is that space for those kinds of tools? Because of course we can have a very simple rule box of this part is too big, this part is too cheap, right? This part is actually, whatever it is, right? Like things that we know right off of a checkbox, like we don't have this material, we don't have this application. And one last question afterwards, I'll write it down to not forget, but how do you think those kinds of tools square up in finding an innovative space and finding a niche in additive?
Well, you kind of give the answer already.
Or maybe you feel what my sentiment is.
No, there are a lot of easy criteria to analyze a part database and to get rid of parts that are absolutely irrelevant for AM. Just like you said, size, euro per kilo, stuff like that. Pretty easy. But that's not AI. So is there a possibility to use some deep learning system or I've seen a lot of presentation or discussion or marketing about that, just like you said, but I haven't really experimented that myself. I'm not sure. I mean, let's put that differently. If I take a look at the actual real niche that we are working in, I absolutely don't see where AI and how AI would have helped us. I mean, when I say us, it's both the customer and us, find these applications and develop them. Absolutely not. So that's of course not
Uh-oh. Okay, yeah, I think we lost Charles. But I guess just to kind of add to that question, what I personally think is that when it comes to AI tools, the challenge is both on the input and the output side. And the input side is how can we have a deep learning algorithm or a deep learning model when we haven't identified the niches as individuals, right? You have to feed that model somehow. And then the next question is after this is done, let's say that does somehow work, is how do we validate that work? Well, we validate that work by having, 100% it works in these situations and 100% it doesn't work in these situations. And that's really hard with AI, because then it just actually means that you have to go back to doing things manually. And of course, it's not just about printing, right? 3/4 of the cost of an additive part can be quality control, depending on what the environment is that you're working in. So the trick is actually to eliminate the applications that don't work. And since there's so many unknowns, we need to focus on that first. And so the AI tools are even less capable of doing that. And so my impression is that these kinds of tools are a solution looking for a problem, and it's just not working. Quite frankly, like that's kind of like self-driving cars right now. It's 20 years out. even though we really hope that it's going to work soon. So yeah, we did lose Charles, but time's up anyway. So perfect exit from him. And thank you again for joining us. The next masterclass is going to be in 3 weeks now, because we do actually have a lot of work to catch up on. And I hope that you're going to be staying safe in the meantime, but we're going to be talking about productivity challenges of multi-laser systems, and I will get a little bit into the qualification process of those, and how that actually impacts productivity. And to be honest, productivity is a BS term. Yeah, just going to go out and say it. Okay, that's not what we really care about. So join me for that class. Like, I'm really going to dig into some topics that I think are very uncomfortable for many people. And we're going to have Stuart Jackson, who's somebody that has been in the industry for, God, I think 20 years. He's a real dinosaur in the best sense possible. He's a really great guy, and very personable and fun to talk to. So join me in 3 weeks, and thank you so much for joining us. We will send you up some follow-ups to actually get your feedback again. And I'm sorry for not answering all the questions, but there were just way too many this time. So thank you again. This has been really, really awesome and enjoyable for me as well. Bye.